All right, so we're still in 10.4 here. Do a couple of examples dealing with maximums and minimums. So, number 28, we are asked to find the maximum or minimum of this quadratic equation. It's a constant battle with the glare here. Okay, so we have, I think, already discussed that the number in front of the x squared term is going to tell you whether this quadratic is going to give you a maximum or a minimum. Remember our general form of a quadratic, ax squared plus bx plus c. If the a term is positive, we're looking at a parabola like this. So if a is positive and if a is negative, then we're looking at a maximum value. If a is positive, we're looking at a minimum value. When a is negative, we're looking at a maximum. In this case, our a is a positive 3, so we know we're looking at a minimum value. And we know the x-coordinate of the vertex is going to be at an x value of negative b over 2a, and then we're putting that value into the function to get the y value. So negative b over 2a, here our a is 3, our b is 3, our c is negative 2. So negative b over 2a gives us negative 1/2. Right? Negative b over 2a is negative 1/2. And then we're throwing that into the function. Negative 1/2 into the function, we get 3 times negative 1/2 squared plus 3 times negative 1/2 minus 2. Negative 1/2 squared is going to be positive 1/4. 3 times negative 1/2 is negative 3/2. And 2. Let's put this all over a common denominator of 4. So we'll say 3 over 4. Negative 3/2 is the same as negative 6/4. And negative 2 is the same as negative 8/4. So once we have the common denominator, we can just add the numerators together. 3 minus 6 is negative 3. Negative 3 minus 8 gives us negative 11 over 4. Now the output at the vertex is going to give us, in this case, our minimum value. So this is our minimum value. That is our answer. Negative 11/4. Again, you can put that into your calculator and check to see that is the vertex. The vertex is at the point negative 1/2, negative 11/4. The output of the function at the vertex is the minimum value. So that's our minimum value for that function. All right. And number 36, again, just a different quadratic function, not in our familiar form. This one was nicely already in our familiar form. This one is not, so we want to rearrange it to put the x squared term first, plus 40x. And we don't see a c, our c is 0. Right? We don't need to put the 0, but that's what it is. So here our a is negative 0.25, and our b is 40. That's the only thing we need to find the vertex. And the vertex, we see the a here is a negative value, so that tells us we have a maximum. Well, we already knew that because that was the question, but it's nice to confirm it and see that a is less than 0, giving us this shape, which gives us a maximum value. So that's what we're looking for. We're looking for the vertex And we know the y value of the vertex, or in this case, the p value of the vertex, is going to be the maximum output. So once again, negative b over 2a, negative b over 2a, so negative 0.5, which is just 1/2, right? So this is going to be a positive 80, right? Negative divided by a negative, 40 divided by 1/2 gives us 80. And then we're plugging that into the function. P of 80, we get negative 0.25 times 80 squared plus 40 times 80. So we'll use our calculator here and say negative 0.25 times 80 squared. That's going to be negative 1600 plus 40 times 80. That's going to be 3200, right? 40 times 80, 3200. So what do we get? We get 1600. And that's going to be the max value of the function, and it occurs at an input of 80. So the vertex is at 80, 1600. The maximum value of this function is 1600, the top of the parabola, the vertex. All right, so maximums, minimums, parabolas, quadratic functions.